AI is everywhere. In your smartphone, in your PC, maybe even in your oven and in games. Some games use AI to predict your moves, others use it to interact with the player. But now the question is, how hard is it to actually make one? Let's find out together. I have trained other AI systems before, but I never used one to actually play a game. So I tried to answer this question by teaching an AI to play Flappy Bird. The game itself is very simple. A bird has to survive as long as possible, jumping and avoiding obstacles. Pretty simple, right? Well, let's see if it will be simple for an AI as well. To train the agent, I used ML agents, which is Unity's official framework for reinforcement learning. But before getting into the implementation, let's answer a very important question. What does reinforcement learning actually mean? Because it sounds fancy, but the idea itself is surprisingly simple. Reinforcement learning is something we all experience every day. Think about a child playing red light, green light. At first, they lose every time. They move when they shouldn't. They stop when they shouldn't. And they basically fail a lot. But step by step, they start understanding the rules and adjusting their behavior. And that is exactly how reinforcement learning works. When the agent does something bad, like crashing into an obstacle, we punish it. And when it behaves well, we give it cookies. A lot of cookies. Training is divided into what we call episodes. Each episode is a single attempt at playing the game. An episode can end when something bad happens, like hitting an obstacle. Each episode gives the agent new experience to learn from. The important thing to understand is that the agent doesn't act completely at random. Sometimes it may look like that, but that's because the agent is exploring different combinations of actions to understand which ones work best in a given situation. And after a lot of iterations, the agent converges to an optimal behavior, which is called policy. Now, all of this logic lives inside a single class in ML agent, the agent. Unity calls a set of specific methods during training, and these methods define how the agent interacts with the game. When training starts, the initialize method is called. This is where I set up references, components, and variables. Basically, everything the agent needs before the simulation begins. Then, every time a new attempt begins, an episode begin is called. This is where I reset the environment, the bird's position, its velocity, and anything else that needs a clean start. During the training, the agent has to decide what to do at every step of the simulation. That decision happens inside an action received. Here, the agent receives an action from the neural network and translates it into an actual gameplay logic. In this project, that action is very simple. Either the bird jumps or it does nothing, which is more than enough to make this game playable. There is also a method called heuristic, which lets us control the agent manually. But this is mainly used for testing or debugging, so it's not used during the training. But the most important method of all is collect observations. This is where we decide what the agent is allowed to see. These observations are the only information the neural network can use to analyze the current state and choose the best possible action. Okay, everything sounds nice, right? But how can you build a project like this? If you want to try it yourself, check out my Discord server. There, you will find all the instructions and files that you need to make it. Oh, you didn't know? Leaving a like and subscribing is the very first step for your project to work. Another very important component is the 2D raycast sensor, which allows the agent to get more spatial observations and actually recognize obstacles in the scene. Now, we are ready to test everything, and even the simplest behavior can take hours to be learned. So, to speed things up, I used a technique based on demonstrations. Before starting the training, I recorded a short demo where I played the game the way I expected the agent to play it. This significantly reduces the time needed for the agent to convert to an optimal behavior. Now we are finally ready to launch the training. And prepare to wait.
One eternity later.
A lot. And when everything is done, the agent learned to play Flappy Bird, jumping with the right timing in order to avoid obstacles and survive as long as possible. Good, really good. But I wasn't satisfied yet, so I decided to make things a bit more interesting, letting the agent choose the jump multiplier. So I went back to the code, I added the force multiplier variable, added a new action to change it, added a new observation to observe it, recorded a new demo, started a new training, and now it's even better. It not only jumps with the right timing, but it also modulates the jump force depending on the situation. And now, a little secret. I originally made this project for an exam called Optimal Control and Identification. And during the course, I also studied a completely different control approach, which is called Model Predictive Control. So, yes, I also implemented another algorithm to control the player or the bird. But this time, it's not AI. It is a mathematical method which I won't cover in this video, but if you're interested, you can join my Discord and get in touch with me. And of course, tell me in the comments if you would like a part 2 where I train an AI to play another game. Bye!